You know, looking at the architectural blueprint for a house is actually pretty fascinating.
Oh, totally.
There is this very specific, like, undeniable logic to it. You see the structural walls, the exact measurements where the electrical lines go. It's clean, it's mathematical, but it's purely structural.
Right. It basically tells you exactly how the house won't fall down. It's just the skeleton.
Exactly. But nobody actually wants to live in a blueprint. I mean, you can't comfortably sit on a schematic of a sofa.
Yeah, it's completely cold.
Right. You need the paint on the walls, the warm lighting, the textures on the floor to actually make it a home. And that transition from a rigid mathematical skeleton to a beautiful, inviting space is exactly what we are exploring today in the digital world.
It really is the moment where web development stops feeling like just, typing raw data into a machine and starts feeling like actual design.
So, today we are taking on a specific mission for you, the listener. If you've been following along with modern web development practices, you've probably built that structural skeleton already. You know, the basic HTML layout rules.
Right, the walls and the wiring.
Yeah, the walls. But today we are bringing that skeleton to life. We're going to dive into the secret language of digital colors, discover how to guide both human eyes and computer algorithms through your text, embed rich multimedia, and finally, look at the literal magic trick that makes those huge desktop websites fit perfectly onto your tiny smartphone screen.
And we're going to look closely at the why behind all of it. Because, every visual choice on the web is still driven by strict underlying logic.
Okay, let's unpack this. If we're going to paint this digital house, we need a palette. In the real world, you just go to the hardware store and point at a can of, like, ocean blue. And technically, CSS, the styling language of the web, it does let you just type the word blue or crimson.
It does, yeah. CSS actually recognizes about 150 named colors.
Which sounds like a lot.
It sounds like a lot until you realize that the human eye can distinguish millions of colors. Real modern design requires absolute precision. You don't just want blue. You want the specific, moody, deep navy blue of your company's logo. Named colors simply can't get you there.
So to get those millions of colors, we use 3 different systems to define our palette. Hex, RGB, and HSL. Now, from what I understand, all 3 of these systems describe the exact same color space.
Yep, exactly the same.
There are just different ways of writing the exact same visual output. But I have to push back a little here. If they all do the exact same thing, why use hex at all?
Yeah.
I mean, it uses this base 16 math where you have numbers and letters mixed together. Like a shade of blue is written as hashtag 1C7293. It looks like literal robot language. Why on earth are there letters in a math equation?
What's fascinating here is that the row that language aspect is exactly why it's so universally used by computers. Hex stands for hexadecimal.
Okay.
In our standard daily human math base 10, we only have 10 digits, right? 0 through 9. But hexadecimal is base 16. It needs to count up to 15 using single characters.
Yeah.
Since we run out of numbers at 9, we borrow the first 6 letters of the alphabet.
Oh, wow.
Yeah, so A represents 10, B represents 11, all the way up to F, which represents 15.
Ah, okay. So it's basically a way to compress larger numbers into a smaller visual footprint.
Exactly. A hex code uses 3 pairs of characters to represent red, green, and blue light. It runs from 00, which is 0 light intensity, all the way up to FF, which is full maximum intensity.
So pure black would just be zeros.
Right. Pure black, the total absence of light, is hashtag 000000. And pure white, all lights turned up to the max, is hashtag FFFFFF. It is incredibly compact. You can just copy and paste a 6-character code without worrying about syntax errors like missing commas or parentheses.
I see. It's the quick shorthand for the machine. But then you have RGB, which literally stands for red, green, blue, and instead of those base 16 letters, it just uses plain numbers from 0 to 255.
Right.
So that same hex color we just mentioned, that 1C7293, is written in RGB as RGB, parenthesis 28, 114, 147. That feels a bit more readable to my human brain.
It definitely is. And RGB has a distinct superpower that Hex natively struggles with, which is the alpha channel.
The alpha channel.
Yeah, that controls transparency.
Yep.
So if you write RGB and add a 4th value at the end, say 0.5, you suddenly have that exact same blue, but it is exactly 50% see-through.
Oh, that's cool.
It's brilliant for creating overlays, shadows, or like glass-like effects over an image.
But if I'm being completely honest, my absolute favorite of the three is HSL, hue, saturation, and lightness.
Oh, it's the best.
It reminds me of the picture settings on an old tube TV or like a mixing console in a music studio. It feels like something built for a human hand to tweak.
It is entirely human-centric. Think about the mechanics of HSL for a second. Hue is simply a degree on a 360-degree color wheel.
So like a literal circle of color.
Exactly. 0 is red, 120 is green, 240 is blue. Saturation is just a percentage of how vivid the color is, from 0% gray to 100% full color.
Got it.
And lightness is a percentage from pure black at 0% to pure white at 100%.
Right. So if I have a primary brand color and I want to create a slightly lighter version for when a user hovers their mouse over a button.
Which happens all the time.
Yeah, doing that in hex requires doing base 16 math in my head. Doing it in RGB means simultaneously calculating new red, green, and blue values. That's a headache.
But in HSL, you just keep the hue and saturation exactly the same. You just bump the lightness percentage up by 10%.
Done. That's so much easier.
It makes creating matching color variations and cohesive design systems incredibly fast.
So we have our millions of colors, we have our palette, but before we just start throwing paint onto our text, how do we make sure we aren't just splashing paint on a collapsing wall? How do we ensure the structure actually holds up?
That's the real challenge.
Let me pose a scenario too that I think literally every beginner runs into. Let's say I'm building a page for you, and I have a random piece of text in the middle of a paragraph that I want to really pop.
Okay.
I want it to be bigger and bolder than the rest. Can I just throw an H3 heading tag around that specific sentence to make it bigger automatically?
I am so glad you brought that up because that is a very common and very destructive shortcut.
Really?
Destructive.
Yes. You should never, ever skip heading levels or use heading tags from H1 down to H6 just for visual sizing.
Why is it dangerous, though? It just makes the text bigger on my screen.
Because headings aren't actually about visual size. They exist to create a literal, invisible structural outline of your page in the document object model, or DOM. Think of it like the table of contents in a textbook.
Okay, I'm following.
Search engines like Google use that outline to understand exactly what your page is about, which directly impacts your SEO.
Oh, so it messes with your search ranking?
Exactly. And even more importantly, screen readers, the assistive technologies used by visually impaired users, rely completely on those headings to navigate the content. If you just drop an H3 in the middle of a paragraph because you like the font size, you completely break the navigation flow for those users.
Wow. Okay. So the absolute golden rule is structure over style. HTML is strict meaning, and CSS is the visual paint.
Precisely. And speaking of strict rules, you must use exactly one H1 tag per page.
Only one.
Only one.
Yeah.
That is your document's main title. Everything else cascades down logically from there. Visual sizing should exclusively be handled by CSS.
Okay, so let's talk about that CSS sizing. I see a lot of modern design using a unit called rem instead of the traditional pixels for font sizes. But wait, if I use rem instead of a hard pixel value, aren't I basically surrendering control of the exact font size to the user's browser settings?
You are, yeah.
Isn't that a nightmare for designers who want things pixel perfect?
Well, this raises an important question about who the web is actually for. Rem stands for root. The root font size is the baseline default set in a user's browser, which is usually 16 pixels.
Okay, 16 pixels.
So if you set a paragraph to 1 rem, it equals 16 pixels. If you set a heading to 2 rem, it equals 32 pixels.
So why not just write 32 pixels in the code?
Because if a visually impaired user has gone into their browser settings and changed their root default size from 16 pixels to, say, 24 pixels so they can comfortably read rem.
Oh, I see where this is going.
Yeah, a hard-coded pixel value in your CSS will override their needs and force the text to be small anyway. But if you use rem, your entire design scales up proportionally based on their new baseline. You are giving up rigid pixel perfection in exchange for universal accessibility, which is a trade-off professional developers make every single time.
That makes total sense. We are building in accessibility from the ground up, not just as an afterthought. And it's not just about size, it's about comfort too. There is a whole psychological aspect to styling main paragraph text. You rarely want to use pure black, that 0000000 hex code, for your reading text.
It seems counterintuitive, right? We always think of black ink on white paper.
Yeah.
But on a backlit digital screen, pure black text on a pure white background creates extremely high contrast. The screen is literally shooting light into your eyes, and that stark contrast can cause eye strain and fatigue over time.
That sounds exhausting.
It is. Using a near black, like a dark charcoal gray, say, hashtag 1A, 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 softens that contrast just enough to make reading long paragraphs much more comfortable.
It's those tiny details that elevate a site. Same with line height, which controls the vertical space between lines of text. A value between 1.5 and 1.6 seems to be the sweet spot. If you use 1.0, the text feels totally cramped and suffocating. But if you go over 2.0, the lines drift so far apart that they feel disconnected, and your eye literally loses its place trying to jump from one line to the next.
It's all about guiding the eye with minimal friction.
But reading is passive. The web is supposed to be an interactive journey. How do we guide the click? How does a browser actually know a specific word is supposed to be a clickable portal to another page?
That is the foundation of the web itself. The anchor tag, written as an A inside angle brackets. The anchor tag uses an href attribute hypertext reference to tell the browser exactly where to go.
And that destination can be a relative path, like linking to an about.html file sitting right next to your current page in your folder, or an absolute path, like typing out the full HTTPS URL to Google.
Yes, exactly.
Yeah.
And if you are linking out to another website using an absolute URL, there's a critical best practice. Always include the attribute target equals underscore blank.
Underscore blank. What does that do?
This instructs the browser to open the new website in a completely separate tab. If you forget this, the user clicks a link and is instantly navigated away from your website. You never want to accidentally kick a user off your own site.
Right. Nobody wants to build a trapdoor for their audience. But how do we make those links visually clear? Because usually, by default, a browser renders links in this harsh, bright blue color with a thick underline. It looks very 1995.
It really does. We can use CSS to strip that away, specifically the rule text decoration set to none, which removes the underline.
Okay.
But if we take away the underline and change the blue color, we introduce a new problem. How does the user know it's a link?
Right. It just looks like normal text at that point.
Exactly. This is where pseudoclasses come in. A pseudoclass is essentially a keyword added to a CSS selector that specifies a special state of the element. The most common ones for links are visited, active, and hover.
Okay, so the state logic is basically the browser constantly watching the element. Is the mouse hovering over it? Is the mouse currently clicking down on it?
Precisely. And styling the hover state is critical. Changing the color slightly and maybe bringing the underline back only when the mouse passes over. It isn't just about making the site look cool or dynamic. It provides essential visual feedback.
Oh, I see.
It communicates instantly to the user's brain. Yes, this element is interactive, you can click me. It fundamentally improves the overall user experience.
Makes sense.
But a quick note on the mechanics here. CSS cascades, meaning it applies the last matching rule it reads top to bottom. If you define your hover state before your normal link state in your code, the normal state will permanently overwrite it and the hover effect will just fail. Order matters immensely.
Here's where it gets really interesting for me. When you look at how standard lists work, the alt unordered list and the list items, there is this massive revelation hiding in plain sight.
Oh, the nav bar trick.
Yes. If you take a standard, boring bulleted list, apply list style set to none to strip out the bullets, add a little margin for breathing room, and then use layout rules to display those items horizontally, you've just built a modern website navigation bar. Every sleek, high-end horizontal menu you see at the top of a website is secretly just a bulleted list in disguise.
It's entirely true. Semantically, underneath the paint, a navigation menu is simply a grouped list of links. Styling it horizontally without bullets is purely a CSS visual trick.
That is wild.
But because it remains a list structurally in the HTML, search engines and screen readers can still perfectly understand that it's a cohesive set of navigational choices rather than just random links scattered across the top of the page.
That is brilliant. Okay, so we have structure, we have gorgeous text, we have interactive navigation, but a wall of text is still a wall of text. How do we integrate complex information without breaking this clean design we just built? What about images and data?
Images are pretty straightforward. You embed them, and you can use your new color skills to add real borders, like a 3-pixel solid hex color. A fun mechanism is the border radius property.
Oh, I've used that one.
Yeah, by manipulating the pixels of the corners, you socken the image. If you set border radius to 50%, CSS calculates the exact center of the image and curves the border completely around it, taking a perfectly square image and instantly rendering a perfect circle.
Instant modern profile picture. But I have to be honest here. When we talk about structured data grids, specifically HTML tables, I cringe a little.
A lot of people do.
Usually when I think of plain HTML tables, I think of those clunky, brutalist, ugly grids from the 1990s internet. They look like a spreadsheet that gave up halfway through. How do we rescue them?
It's a completely fair reaction. Unstyled tables are notoriously ugly. But first we have to understand why they have that reputation. In the late 90s, before CSS was powerful enough to handle complex layouts, developers used invisible HTML tables to structure entire web pages.
Oh,
Yeah, they would put the navigation in one cell, the main content in another cell, and the footer in the bottom row.
I remember those days. It was an absolute nightmare to maintain.
Exactly. So the absolute rule today is that tables must be used strictly for displaying actual data relationships, like a schedule, a pricing tier, or a roster, never for page layout.
Got it. Data only.
Right. The HTML structure itself is highly logical. A table tag wrapping the whole thing, try to define each table or row, terth for header cells at the top, which naturally render bold and centered, and save for the actual data cells.
Okay, the logic is sound, but how do we stop them from looking like they're from 1996?
We use a specific CSS rescue package. First, border collapse set to collapse. By default, a browser gives every single individual cell its own separate border, creating a messy double-line grid with awkward gaps between cells.
Oh, right, that weird double border.
Yeah, border collapse merges all those adjacent borders into single, clean, razor-sharp lines.
Oh, that immediately changes the visual hierarchy.
Then we apply padding to the cells. Without padding, the text is smashed right up against the grid lines, creating immense visual tension. Padding forces invisible space between the text and the cell wall, giving the data room to breathe.
Much better.
Finally, we use a structural CSS selector called tricolon nth child parenthesis even.
That sounds complicated.
It's actually simple. This looks at your table, automatically counts the rows, and applies a subtle background color, like a very light gray, only to the even-numbered rows. It creates a zebra striping effect.
That is fantastic. It creates a horizontal track that guides your eye right across the row so you don't lose your place. If you were styling something like an IT help desk schedule for a university, say Soella Technical Community College, you can see how applying just those three things, collapsed borders, padding, and zebra stripes, turns a raw, intimidating wall of data into a highly scannable, deeply professional schedule.
It really is the difference between data and information. Data is raw, but information is organized and readable.
We also can't talk about rich data without touching on the audio and video tags. For a long time, embedding video meant relying on third-party plugins or just pasting an iframe from YouTube.
Flash player, anyone.
Oh, don't remind me. But now we have native HTML tags for embedding actual media files living right on your server. However, there is one crucial attribute you absolutely must include or the whole thing breaks.
Yes, the controls attribute. Here is the mechanical reality. If you write a video tag and point the source to your MP4 file, but you forget to tuck the word controls inside the tag, the browser will load the video, but it won't render a visible player interface.
Wait, really?
Really. There will be no play button, no pause button, no volume slider, no timeline. It will literally just be a frozen frame of your video sitting dead on the page, and the user will have zero way to interact with it.
That's terrible.
It is. The controls attribute is the explicit command that tells the browser to generate its native, built-in media player interface on top of your file.
It's a literal make-or-break word.
Yeah.
Okay, so let's take a step back and look at what we've built. We have this gorgeously styled page. We've got precise hex colors, beautifully spaced typography, scaling perfectly with rem units, a sleek horizontal navigation bar cleverly disguised as the list, highly readable zebra-striped tables, and embedded video players functioning natively. It's an absolute masterpiece.
It is assuming you are looking at it on a large computer monitor.
Right, because there is a looming disaster here. What happens if our user, you the listener, takes this masterpiece we just built and opens it on a tiny smartphone screen while riding the bus?
Well, if you've built it with fixed widths, say you locked your layout to be exactly 1,200 pixels wide, it's going to be a frustrating disaster.
Why?
A standard phone screen is only about 400 pixels wide. The content will wildly overflow the screen, and the user will be forced to physically pan and scroll sideways just to read a single sentence, then scroll all the way back to catch the next line.
Yes.
It is arguably the worst user experience possible.
It's exhausting just thinking about it. But wait, why doesn't the phone just automatically shrink the website to fit the screen?
Well, historically they did, and that's actually the problem. When the first modern smartphones, like the original iPhone, came out, the web was entirely desktop-focused. If a phone tried to honestly render a 1,000 pixel wide site on a 320 pixel screen, the layout would be completely broken.
Right.
So mobile browsers were programmed to lie. They would pretend their screen was 1,000 pixels wide, render the desktop site, and then aggressively zoom out so the entire thing fit on the tiny screen at once.
Oh, I remember those legacy sites where you load the page and the text is literally microscopic and you have to desperately pinch and zoom just to find the login button.
Exactly. That was the compromise. But today, responsive design is the absolute baseline reality of the modern web. A website must automatically adapt its layout to perfectly fit whatever device is viewing it.
Right, whether it's TV or a watch.
Exactly. And solving this begins with countermanding that historical legacy, using one critical line of code in the head of your HTML document, the viewport meta tag.
Okay, looking at the syntax, it's a meta tag with name equals viewport and content equals width equals device width, comma, initial scale equals 1.0. How exactly does that fix the microscopic zooming issue?
The viewport meta tag essentially commands the mobile browser to stop lying. Width equals device width tells the browser to report its actual physical pixel width.
Okay, so it admits it's only 400 pixels wide.
Right. And initial scale equals 1.0 forcefully locks the zoom level at 100%. It forces the browser to honestly confront the narrow screen size without trying to shrink the content.
So what does this all mean? If we force the phone to honestly look at a narrow 400 pixel screen, our 1200 pixel layout is still structurally broken, right? It still falls off the edge.
That is exactly where the second half of the magic comes in, media queries inside your CSS.
Okay, the syntax for a media query looks like at media, parenthesis, max with colon 600px. It sounds to me like a media query is basically an ISBN bouncer standing at the door of your CSS code block.
A bouncer, I like that.
Like if the browser window is super narrow, 600 pixels or less, then allow these specific CSS rules inside to execute, maybe changing the layout from 3 columns to a single neat vertical column. But if the screen is wider than 600 pixels, the bouncer says, no entry, ignores those specific rules, and keeps the multi-column layout. Am I reading the logic of that right?
If we connect this to the bigger picture, your bouncer analogy is spot on. Media queries allow you to create conditional styling. The browser constantly asks, what size am I right now? And applies different CSS rules accordingly.
That's so smart.
But the synergy here is paramount. Without that single viewport meta tag in the HTML telling the phone to report its true width, the media queries in your CSS will never trigger correctly on mobile because the phone will always claim it's a wide desktop. They fundamentally require each other to function. Responsive design is the definitive line that separates a hobby project from a professional production-ready website.
It really is an ecosystem where everything relies on everything else. The HTML provides the truth, the meta tag sets the boundaries, and the CSS paints the reality based on those conditions. To recap the incredible journey we've been on for you today, we took a plain, unstyled HTML document, a rigid, cold skeleton.
We gave it some life.
We really did. We learned how to paint it using the exact base 16 math of hex codes and the human-friendly logic of HSO. We gave our text a strict, invisible outline that search engines and screen readers can flawlessly navigate while keeping the visual sizing safely contained in our CSS using scalable DOM units.
Structure over style, always.
Always. We styled interactive pseudo-classes to visually guide our users' clicks, and we used a brilliantly simple CSS magic trick to turn a stripped-down bulleted list into a sleek horizontal navigation bar. We rescued HTML tables from the clunky 1990s by collapsing borders and striping the rows, embedded media natively with that vital controls attribute, and finally ensured the whole thing shapeshifts perfectly for a mobile screen using the viewport meta tag and our CSS bouncer, the media query.
It is an immense amount of power at your fingertips. By mastering the intersection of structure and style, you aren't just making things look pretty, you are engineering usability.
You are fully equipped. You've got the paint, the brushes, and the deep understanding of the canvas.
I'd like to leave you with one final thought to ponder as you step out of this deep dive. Every beautiful, seamless, emotionally resonant website you have ever visited, the ones that feel perfectly alive, effortless, and intuitive, is ultimately just a highly organized pile of strict syntax rules, invisible geometric boxes, base 16 math, and conditional logic masquerading as art. Consider this the next time you're browsing your favorite site. At what exact point does the rigid mathematical code disappear from your mind and the human experience actually begin?
Oh, I love that. Until next time, keep exploring.